yeah, let's just write down some more of those math facts. That you are totally allowed to use. I don't want red for this. I don't want it. Sounds like more of a job for pink. Oh, that's much better. Ooh. Math facts. So we already said that if U is universal set, then A complement union A equals U. We also already said that if U is universal set, then A complement equals U minus A. Right? That's exactly what it is. That's why sometimes people call the set difference the relative complement, right? Because if you look at like A minus B, what that's saying is take everything in A. Oh, you can see that. That's saying take everything in A, except for the things in B. So take out all the elements of B. But in a certain sense, this is just like exactly what B's complement would be if A was the universe. So that's what they call it relative complement, because relative to A, this is the complement of B. But anyway, so yeah, this fact. We also have the fact that this is an interesting one. A intersect A complement. What's that going to be, you think?
Blank.
Blank. Yeah, empty set. A intersect A complement is null. Like it is the empty set because A complement is defined to be just everything that's not in A. So by definition, they can share no elements. Yeah, and so these are a bunch of cool math facts that you are totally allowed to use. Maybe I'll prove some next time, but for now, it's 3:30. So say goodbye. 4 classes left. And that's that. Does anyone have any questions for me? Okay, well, no questions. Then I cannot wait to see you guys next time. We'll talk about some very interesting ways to do this. Like sets and logic have so much going on. There's so much parallels. Like remember, like I said, we had statements, and the first thing we did with statements is we created logical operations. The first thing we do with sets is making set operations. But what's the next thing we did with logic? After we logic operations, we talked about logical identities. Remember De Morgan's law, identity law, all those weird laws? Basically, all of those laws apply to sets as well. There's analogous laws for sets. It's really interesting. And it all has to do with the fact that and intersection are linked and union and or are linked. It's interesting. We'll do that next time. So for now, bye. Thanks for coming, everybody.